Good evening, everyone. Thank you for joining us. Bonsoir tout le monde. I'm Catherine Spencer-Ross, Chair of Heritage Ottawa's Lecture Series Committee. It gives me great pleasure to welcome you to our first presentation of the 2021-2022 lecture season. This will be the first in a series of lectures about the Alexandra Bridge that will be presented by Heritage Ottawa over the next few years. As many of you know, the federal government has determined that the Alexandra Bridge has come to the end of its lifespan, no pun intended, and needs to be replaced in about 10 years. Heritage Ottawa has joined with others to create the Alexandra Bridge Coalition, which hopes to convince the federal government instead to repurpose the existing bridge for active transportation. You can find out more about the Alexandra Bridge Coalition on the Heritage Ottawa website. Before we begin our lecture, I take this opportunity to thank our sponsor, Andrex Holdings, Inc. and Sandy Smallwood. Andrex has been a faithful sponsor of these lectures, as well as of our walks and some publications. We also recognize and thank the City of Ottawa for its operations grant to Heritage Ottawa and the Province of Ontario for its Heritage Grant. In welcoming you to this lecture, I'd like to thank those of you who have made donations to Heritage Ottawa and encourage this very concrete form of support. For those of you who are not yet members, I would also encourage you to join us. Please connect with our website for information. I'd now like to introduce our speakers for this evening, David Jeans and John Zvonar. David Jeans is a retired professional engineer who worked at Bell Northern Research and Nortel in Ottawa. He is a former president of Transport Action Canada, a national advocacy group for public transport, and was also president of Heritage Ottawa. He has been on Heritage Ottawa's board since 2002 and has been assisting with the organization of Doors Open Ottawa and guiding heritage walking tours every year since then. David has a strong interest in railway history and railway station architecture, and belongs to numerous railway-related societies. In 2001, he organized a celebration of the centenary of the first train to cross the Alexandra Bridge, and he has written and lectured about the bridge often since then, and conducted a new Heritage Ottawa walking tour to the bridge last month. John Zvonar is a new Heritage Ottawa board member. He has recently completed a long run at the federal government's Center of Expertise in Heritage Conservation, employing a values and principles-based conservation approach in protecting nationally significant cultural landscapes, notably for Parks Canada and within the parliamentary and judicial precincts. He also continues his active involvement with the Friends of Maple Lawn Garden, the Alliance for Historic Landscape Preservation, and serves as the Canadian voting member with the ICIMOS IFLA International Scientific Committee for Cultural Landscapes. John was honored with his election to the Canadian Society of Landscape Architecture's College of Fellows in 2014. Since his arrival in Ottawa from Thunder Bay and Winnipeg, John has been infatuated with the Alexandra Bridge. I am now very pleased to ask David to begin his presentation. He will be followed immediately by John Zvonar.
First of all, I'm going to be talking about the history and the engineering significance of the Alexandra Bridge, and particularly focusing on how and why it was built. What was the rationale for an interprovincial bridge? In fact, a second interprovincial bridge, because the Prince of Wales Bridge, which is now called the Chief William Commander Bridge, was built as a railway connection across the Ottawa, connecting Montreal and Le Breton Flats back in 1879 to 1880. That bridge, however, was owned by Canadian Pacific, and their monopoly and the location of their station on Le Breton Flats wasn't particularly suitable for all railways, particularly three railways that were formed on the Gatineau side of the river later on: the Pontiac and Pacific Junction Railway, which went up through Aylmer and had reached Fort Coulange by 1888, and the Ottawa and Gatineau Railway, which went from Hull north and had reached Gracefield by 1895. Finally, the Hull Electric Railway, which was a streetcar line operating between Hull and Aylmer, all of those railways wanted access to Ottawa, and the Prince of Wales Bridge wasn't suitable for that purpose. Now, who were the people who made it happen? Well, first of all, top left, J.R. Booth, I think everybody knows. Not everyone realizes that he was a railway magnate as well as a lumber king. He built a 400-mile-long railway, which included many bridges, including a long bridge over the St. Lawrence River, which cost $1.5 million to build and was 3 times as long as the Alexandra Bridge would be. And he was great at raising money for large-scale projects. However, it was Horace Jansen Beamer who was the entrepreneur who actually made the interprovincial bridge happen. He was an American contractor. He'd worked on the Welland Canal. He'd built railways all over Quebec. He was actually president of both the Pontiac and the Gatineau Railway. He'd built the city gates, the old city gates for Quebec City, and the waterworks and aqueducts for Montreal and Quebec. And finally, he had, in 1880, he'd built the stone piers for the Prince of Wales Bridge. He also knew how to raise money. Third person, Guy Dunn, one of those people standing top right at the last spike ceremony for the Grand Trunk Pacific Railway, which happened in 1914. He was the chief engineer of the Gatineau Railway. He designed the bridge. He laid it out on the ice of the Ottawa River. He did his test drilling through the ice to determine the condition of the bottom. Then there were and he supervised the construction of the bridge throughout the project. Then there were the engineers and contractors who actually built it. Charles Herbert Deans, I don't have a picture. He was an American, and he was a specialist in building bridge piers. Then Phelps Johnson, George Duggan, and Fred Sherwood were successively the presidents, the chief engineers, each of them, as well as the presidents of Dominion Bridge Company, which was Canada's leading bridge construction company. Men of great experience, and all 3 of them worked on the design of the Alexandra Bridge. Now, government support was important. Beamer was able to raise eventually about 40% of the estimated $750,000 cost of the bridge from governments. Mayor Samuel Bingham, who actually had significant lumbering interests in the Gatineau Valley, pledged $150,000 for the city of Ottawa. Wilfrid Laurier's government, $112,500, which was 15% of the expected amount, though the federal government later raised that amount by $100,000 because of project delays which were caused by the government rather than by the entrepreneurs. Collingwood Schreiber was his deputy minister of railways and canals and was really Canada's most eminent engineer at that time, really successor to Sanford Fleming in his importance in Canadian engineering. Finally, on a lesser scale, Arthur Sturgis Hardy, Premier of Ontario, pledged $50,000, so long as Quebec would also ante up the same amount. Quebec refused, partly because it had paid for the Prince of Wales Bridge 20 years earlier and didn't really see why it had to pay for a second bridge into Ottawa. Now, the place that was decided to construct the bridge was off Nepean Point, but the river was very difficult here. It was deep, it was fast flowing. It was an important channel for steamboats to the Rideau Canal and the steamboat wharf, which Colonel By had constructed, which you see on the far right, and also was a major transportation river for lumber, both the logs that you see in the foreground and the large timber rafts. So there were big problems with the river because at this point, they discovered through the test drilling that there was a mountain of sawdust 60 feet high on the river bottom. And the original plan, which would have been a conventional bridge with evenly spaced piers, was not possible because they couldn't excavate through that sawdust mountain. So they had to adopt a different bridge technique, quite novel. Its first use in the United States was in 1877, called the cantilever bridge. And with this bridge approach, they did not need a pier to support the bridge in the middle of the river. The reason for that, if you look at the middle of this page, is that a cantilever consists of 2 parts. It's supported in the middle. You can see the up arrow. But the portion of the bridge to the left, which is called the anchor arm, actually holds the bridge down, and the cantilever arm, which extends out over the river, is therefore counterbalanced by the anchor arm and a downward weight, which is at the shore end of the bridge on the extreme left. So this was a complex bridge design, and you can see from the complexity of these design drawings the work that Dominion Bridge had to do to come up with the plan. Looked at from above, you can see the extensive cross bracing that had to be included because of the amount of wind that affected such a tall bridge. And also because the funding from the City of Ottawa was conditional on providing road decks for carts, cars, to use the bridge toll-free in perpetuity. And those had to be added on the outside edge of the main railway bridge. Now, there were a number of cantilever bridges that had been built in Canada before, all of them shorter in span than the Alexandra Bridge was going to be. The first one was over the Niagara Gorge in 1883, and the second in St. John, New Brunswick, near the Reversing Falls. But all of these were railway bridges. The third in Cisco, British Columbia, over the Fraser River Canyon. The fourth, a double span bridge at Lachine, which carried the Canadian Pacific Railway over the St. Lawrence River. And there you see how the bridge could be built out over the river without support, because it's the shore spans, the anchor arms that you can't see that are just out of the picture frame, which are holding down their end of the bridge and counterbalancing the portion over the river. And then you can see there's also a pier in the middle of the river. There are several reasons for building this kind of bridge, either because the gorge is too deep to have scaffolding underneath, or because it's a shipping channel, such as the case with the St. Lawrence River. The last bridge of this type was actually built at the same time as the Alexandra Bridge in Cornwall for the New York Central Railway, and you see it there. Two of these bridges were actually built by Dominion Bridge, the Lachine Bridge and the St. John, New Brunswick Bridge. So they had direct experience with building cantilever bridges. On the world scale, the famous cantilever bridge was the Forth Bridge in Scotland, which is actually a double span. You can see there are 3 cantilever arms and therefore 2 long spans over the Firth of Forth. And this was, each of these spans was about triple the length of the distance that had to be spanned over the Ottawa River. This was a massive bridge, and it really set the standard for cantilever bridges. The other 2 that I show here are the only 2 in the world that were actually longer than the Alexandra Bridge when it was completed. The Frisco Bridge in Memphis was about 50% longer than the Alexandra Bridge, and the Liberty Bridge in Budapest was actually 18 feet longer in span than the Alexandra Bridge was going to be. So the Alexandra Bridge, when it opened, was really the 4th longest cantilever span in the world. Now, the start of construction in 1898 was the contract with Charles Deans, the American contractor. You can see the picture on the bottom left. Just imagine that the bridge is not there and look at the piers. You can see how the 2 piers nearest us on the Hull side are built of limestone blocks. The next 3 piers are actually in the water, and the underwater portion is concrete, whereas the portion above water is limestone blocks. And then there's another pier on the Pean Point on the far left of the picture. So these piers presented challenges. The first 2 on the Hull side, which you see above the picture, number 5 and number 6, were easy to do because they were just a concrete base on bedrock and then masonry on top of that. The river piers were more difficult. They were done by putting wooden forms down to the riverbed, excavating the sawdust because there was still some sawdust for each of the piers, and then pouring concrete into the water. The concrete hardened underwater, and when it reached just below water level, they then completed the pier with masonry on top of that. The problem was when they got to pier number 2, which was nearly 90 feet high, the Canadian government put a stop to construction because there was an accident on that other bridge I showed you, the cantilever bridge at Cornwall. On one portion of that bridge, one of the bridge piers was swept away and the bridge collapsed with a multiple fatality accident. And because it wasn't clear why that had happened, particularly since the same construction technique was being used, the federal government called a halt for nearly a year to the construction of the Alexandra Bridge. In order to prove that the concrete was sound, the contractors had to diamond drill a core right down to bedrock through the concrete and extract the core, which could then be examined to determine that, yes, the concrete was in fact sound all the way to the riverbed. So in 1899, they were allowed to resume construction and finish the piers. The next step was to build the bridge superstructure. It was all done in 1 year. Dominion Bridge got the contract in September of 1899, delivered the steel by rail from their factory in Lachine to the Hull side of the river in the latter part of 1899. And then the entire bridge was erected between January and October 1900. Now, I'm going to just go through these pictures individually just to show you how it was done, because it was quite an engineering accomplishment. They started work in the winter and were able to complete the first 2 spans on the Hull side. You'll notice, though, that the second span that they're working on is actually supported by scaffolding that's floating on 4 steel barges or scows. The reason they did that was that they were able to adjust the height of that scaffolding in the water by pumping water in or out of those scows. So it was floating scaffolding or floating falsework that could support the construction of the bridge above. And although it was difficult maneuvering those scows in January, they had a great deal of difficulty clearing enough of the river ice in order to get the scows into position, but they were able to build that bridge span. Next, they built the bottom part of the anchor span of the first cantilever. They built it on the Hull side of the river, but in April of 1900, they floated it across the river to the Ottawa side with the help of 2 Ottawa-based tugs. And they're pulling those 4 steel scows with the entire scaffolding and bridge deck sitting on top. And they towed it downstream, turned it around 180 degrees, pulled it back upstream between the piers, and then maneuvered it over to the Ottawa side and dropped it onto that bridge pier that you can see in the water in the foreground and attached it to the steel girder that you see sticking out of the right frame of the picture. So that was how they were able to build where the steel had been delivered by rail on the Hull side of the river, but still managed to move everything over to the Ottawa side. And then they could complete construction of the first cantilever on the Ottawa side by June. You can see that the anchor span, which it reaches back to the pier at Nepean Point, is complete here, and they are currently building out over the water with a traveling crane, that rather spindly looking device, which ran on rails along the bridge and was able to lift steel girders into position up to 60 feet in front of the front edge of the bridge. So that extended right to the middle of the river, and then they moved everything back to the Hull side. You can see the scows and scaffolding floating between piers 3 and 4 on the Hull side there, and they're doing exactly the same thing. They're building they've completed the anchor arm of the Hull cantilever, and they're now building out to the middle of the river. So by October, they were able to join the 2 together, and for that they moved the floating scows right to the middle of the river, jacked them up by pumping out the water so that they supported the 2 parts of the bridges in exact alignment, and then put in the 60 feet of extra steel just to join the 2 pieces together. And then the bridge was complete. Dominion Bridge finished their work in November of 1900. Now, I just want to mention here, I've been referring to it as the Interprovincial Bridge. It was built by the Interprovincial Bridge Company. It was called the Interprovincial Bridge on the day that it opened. But in 1901, Mayor William Morris of Ottawa proposed that it should be renamed the Alexandra Bridge in honor of the royal visit of Queen Alexandra's son, the Duke of Cornwall and York. He was later King George V, and that it could be named at a ceremony when he and the Duchess of Cornwall and York, later Queen Mary, were in Ottawa. The picture at the top shows part of the ceremony dedicating the statue of Queen Victoria, which they did do, but they never dedicated the Alexandra Bridge. And that was a bit of an embarrassment. Horace Beamer, on the mayor's suggestion, had actually put up electric lights on the bridge. They're a little hard to see in this picture, but they do spell out the name Royal Alexandra in lights on the bridge, and you can see it in this photograph taken from the roof of the West Block. Unfortunately, neither the mayor nor the Canadian government had consulted Buckingham Palace, and so naming the bridge Royal Alexandra was a violation of protocol. As a result, the Alexandra Bridge has never been the official name, but it has been the popular name ever since 1901. Now, how the bridge was used, the first trains were able to cross the bridge immediately after Dominion Bridge completed their assembly work. Here are 4 locomotives who are load testing the bridge in December of 1900. And the first train from Gatineau came into Ottawa over the bridge on the 22nd of April, 1901. And as Catherine mentioned at the beginning, that was the event whose centenary we celebrated at the bridge on the 22nd of April, 2001. We had guests from elected representatives from both sides of the river, representatives of the Canadian Society for Civil Engineering, local historical groups, and we even had an STO bus come across the bridge right at the time of day that the first train from Gatineau had arrived. And it was a modern bus with electronic sign on the front. So it was signed Interprovincial 100. And that was quite an exciting event, which we held. Now, the other use of the bridge was for, I've mentioned already, the road decks. If you look at the picture, top left, you can see how the road decks were cantilevered out either side of the main steel trusses. And on those road decks, there were also tracks for the Hull Electric Railway streetcars. Here you can see 2 of them coming and going to and from the bridge. They operated over the bridge from July 1901 right through until 1946, when there was a major fire in the E.B. Eddy lumber pile, which you can see in the background of this photograph. And that fire destroyed the approach to the Hull end of the bridge for streetcars, and that was the end of electric streetcar service in Hull and connecting Hull into their station at the Château Laurier. But the most important railway use of the bridge took place from 1902, when Canadian Pacific actually bought this bridge as well, and the railways, the Gatineau and the Pontiac railways, which had actually been the railways that built the bridge. And it operated its transcontinental trains between Montreal and Vancouver over the Alexandra Bridge right up till 1966, when Union Station was closed and the railways were moved, the railway lines and station were moved out to Alta Vista. Now, I want to mention also, I'm drawing to an end here, but the Quebec Cantilever Bridge is very famous because it's not only the longest cantilever span in the world at over 1,800 feet, but it's also the most infamous bridge in the world, because when it was built, due to engineering errors, it collapsed with a loss of nearly 80 lives in 1907. And there were a number of issues with the consulting engineer and the Phoenix Bridge Company, which built it. Curiously, and this is just a coincidence, the chief engineer of the Phoenix Bridge Company in charge of this project was the brother of the Charles Deans who had built the piers for the Alexandra Bridge. So, you know, it's a small world, but anyway. The next small world aspect was that those three men that I showed you from Dominion Bridge who designed the Alexandra Bridge, George Duggan, Phelps Johnson, and Fred Sherwood, actually designed the replacement bridge at Quebec, which was completed in 1917, but not after. There's an error on this slide. In 1916, during the final lift of the suspended span to cross the middle of the river between the two cantilevers, it collapsed into the river because of a failure of a metal component. It wasn't a design error this time, and unfortunately killed more construction workers. But the bridge was still successfully completed in 1917 and has stood there, the longest single cantilever span in the world, carrying both a railway line and a road. Now, in 1966, as I mentioned, Union Station was closed. And in 1975, the National Capital Commission did a complete rework of the bridge to put a road deck down the middle where the railway line used to be, to keep cars operating on the downstream side of the bridge, but to convert the upstream side, as you all know, to a pedestrian pathway and a bicycle path. And that has been its role since then. There's been extensive maintenance done over the years, and I'm not going in detail into this because it's really going to be part of a later Heritage Ottawa lecture, which you'll hear about later. But the work has really been pretty much continuous since about 2009. The bridge was completely repainted in 1995, but a major steel repair job was done dealing with a lot of corrosion between 2009, 2011. The road deck had to be completely replaced, as was the boardwalk. An inspection walkway was constructed underneath the bridge, and there has been since then been a great deal of ongoing, almost continuous repair work, safety monitoring, and inspections, and that is continuing. Just to mention here, looking at these two pictures, a cantilever bridge of the early design is very complicated because it consists partly of steel columns, like the latticework column that you can see running diagonally on the picture on the right, and link bars with holes in the end, which are bolted or pinned together. The link bars are the parts of the bridge that are in tension. The steel girders, built-up girders or columns are in compression. And the pins that hold the whole thing together are critical to the stability and safety of the bridge. When you get a failure of a cantilever bridge, it can be catastrophic. You saw the picture of the collapse of the Quebec Bridge. And there was a similar cantilever bridge collapse a few years ago in Minneapolis. So the condition of these components on the bridge is critical from a safety point of view, and they are being monitored very carefully. You'll hear more about that later on. From a designation point of view, the bridge has no legal protection status, but it was designated in 1995 as a National Historic Civil Engineering Site. This designation was by the Canadian Society for Civil Engineering, and they placed bilingual plaques on the bridge. These were, of course, in addition to the commemorative plaque which Dominion Bridge had put up in 1900. There are 4 of these plaques, 2 in English and 2 in French, which are on the end of the bridge. And then finally, there is a government plaque which doesn't convey any degree of government protection because the bridge is actually owned and maintained by Public Services and Procurement Canada, and we'll be hearing more from them later in the year. What we're facing right now is a proposal from the government that the bridge needs to be replaced in about 10 years' time. And I'm not going to be talking about that tonight. Again, that's the subject of a future talk, except that the consultant proposals so far have looked at either replacing it with a replica that would look something the same, a signature bridge, which would look quite different, but would be making an architectural statement of some sort, or a rather utilitarian contemporary bridge. And as you have heard, the Alexandra Bridge Coalition is opposed to all three of these options and would much rather see the bridge repaired and maintained as it is and turned into a green pedestrian and cycling facility. So at this point, I'm going to say thank you, and I'm going to turn it over to my colleague, John Zvonar, and you can just take this last look at the bridge as it appeared from the Rideau Canal in 1901.
Well, thank you, David, and thanks to everybody. Good evening. Historically and metaphorically, bridges have long served as indelible icons and have been embedded in our collective subconscious. I grew up in Thunder Bay, and my coming of age included a swing bridge over the Kaministiquia River, my connection to day camps and swims at Chippewa Park. The bridge was built in 1909, so to connect the new transcontinental railway and Prairie Grain shipments with the Lake Superior port. It remains front of mind as one of my earliest memories of bridges. Since then, numerous examples spring to mind: the Tower Bridge in London, or the Forth Bridge in Scotland, or closer to home, the Brooklyn Bridge, or the Golden Gate Bridge on the West Coast. And in as much as they are appreciated, it is only when they are exposed or succumb to any number of threats that communities rally to either save them or to reconstitute them. The following section will examine a few case studies, generally from the point of view of history, threat and damage, and community response. And while there may be better examples, there certainly are more examples. The point is to illustrate the tradition of enthusiasm within communities, large and small, towards protecting their cherished engineering heritage. The Chapel Bridge is a wooden footbridge in Lucerne, Switzerland, originally built about 1365 as part of the town's fortifications. The key part of the bridge complex is the octagonal water tower, which predates the bridge proper. The watercolor to the right, for those of you who will know the name, was actually done by John Ruskin. It remains the oldest wooden covered bridge in Europe, as well as the world's oldest surviving truss bridge, and serves as the city's symbol and as a Swiss cultural property of national significance, is one of the nation's main tourist attractions. On 18th of August, 1993, a devastating fire consumed the landmark bridge and triggered reactions from around the world, sort of akin to what took place two and a half years ago with Notre Dame Cathedral in Paris. Researchers immediately began documenting every element of the bridge, including an inventory of each and every beam. A mere 3 months following the fire, approval was given to reconstruct it as it was. Elements that were damaged and that could not be repaired were removed, and intact tiles salvaged for reuse. Following an old carpenter's tradition, a small topping out ceremony was held in February of 1994. 2 months later, the construction work was complete, a mere 8 months from the date of the fire. The starry old bridge is a reconstructed 16th century Ottoman bridge in the city of Mostar in Bosnia and Herzegovina. The original bridge was completed in 1566 and stood for 427 years until it was destroyed in November 1993 during the Croat-Bosniak War. In October 1998, UNESCO established an international committee of experts to oversee the design and reconstruction work. The committee decided to build a bridge as similar as possible to the original, using the same technology and materials. The World Bank, UNESCO, the Aga Khan Trust for Culture, and the World Monuments Fund formed a coalition to oversee its reconstruction. The work commenced in June 2001, and the reconstructed bridge was inaugurated in July 2004. Now, if you're like me, in the past year and a half, you have connected to many organizations near and far by way of webinars. One such group, the World Monuments Fund, offers a series on the World Watch List, which includes 25 sites that marry great historical significance with contemporary social impact. One topic that I felt germane to tonight's discussion was that of the Bennerley Viaduct in central England. The Bennerley Viaduct was built in 1877 to carry a new railroad line across a river valley. At over 1/4 of a mile long, longest wrought iron viaduct in the country, the structure needed to be sufficiently lightweight so to prevent underground mining tunnels from collapsing beneath its weight. The last freight train crossed the viaduct in 1968, at which point the viaduct was taken out of use. While proposals for its demolition were met with local resistance, the structure stood for many decades without a function and was finally sold to a conservation group in 2001. Today, the Friends of Bennerley Viaduct have embraced a vision to reclaim the hulking structure and to open it to community use. And I took a number of screenshots from that presentation back in the summer to share tonight, including what you see on the screen. The process enables volunteers to become actively involved in a regeneration project and to capitalize on the industrial heritage of their community. Ultimately, through an active website and good communications, the Friends are dedicated to giving the Iron Giant a new lease of life through restoring, conserving, and celebrating. This year, the Bennerley Viaduct was reopened to the public after 50 years with the support of the Railway Heritage Trust, the Heritage Fund, Historic England, and of course the WMF, who will support the establishment by the Friends of an effective governance structure to ensure its long-term future. Now, on this side of the Atlantic, a number of recent examples serve as suitable case studies of threatened or damaged bridges supported by a variety of communities. The Kinsale Trestle is a wooden railway bridge in the Cowichan Valley on Vancouver Island. Started in 1911 by the Canadian Northern Pacific Railway, it was taken over by Canadian National Railways in 1918 and completed in 1920. It was built so to provide a more efficient way to transport the region's old growth timber. The largest wooden trestle in the Commonwealth of Nations and one of the highest railway trestles in the world, it remains one of the few accessible and visible reminders of the early mining and logging industries in this area and supports tourism and recreation. The last CN train to cross the trestle was in 1979, at which point it fell into decline. In time, due to its deteriorated state, neither walkers or cyclists were permitted to use it. Consequently, it was in danger of being torn down as it was said to pose a public risk. Community groups then raised money to preserve the trestle for its historical and tourism value, whereas others simply wanted to repair the break in the route as quickly and as cheaply as possible to offset a lengthy detour. In June 2007, the Cowichan Valley Regional District considered a conservation strategy proposed by local building conservation specialists that would see the bridge fully restored for pedestrian use. The feasibility study was subsequently approved, and by November of that year, a major inspection of the trestle was conducted and concluded that 80% of the major timbers were still sound and thus feasible for the restoration. Phase 2, that is a detailed plan of restoration, was delivered in November 2008 at an estimated cost of $5.7 million. With the recognition that the structure would be preserved and rehabilitated, an official community-based Save the Historic Kinsale Trestle campaign raised the remaining $2 million necessary to complete the work. The official reopening of the trestle was in July 2011, and it is now a critical part of the Trans-Canada Trail and the Vancouver Island Trail. And as you can see, it is still there. The Kettle Valley Railway was built in the early 1900s in BC's Okanagan Valley. The last train ran on the tracks in 1964, at which point the railway slowly fell into decline until the early 1990s, when a campaign began to restore the structures. In the early 1990s, volunteers with the Myra Canyon Trestle Restoration Society began restoring the 18 structures in that canyon along its 12-kilometer route. Regrettably, most of that initial restoration work was destroyed by the 2003 Okanagan Mountain Park forest fire, and 43 structural timbers were compromised, either broken by rockfalls or by falling trees. While it is said that repairing Kettle Valley Railway trestles is not for the faint of heart or the impatient, there is no question that the restorative work would be done. The last of the burnt trestles was rebuilt in 2007, but it then took almost a year to coordinate the materials to replace the remaining broken Douglas fir beams. The Society still does maintenance and other works, although the trestles are now part of the Myra Bellevue Provincial Park and protected area. Ultimately, most of the trestles were built to rigorous historical standards, that is, strong enough to carry trains, and should last another 100 years, carrying increasing numbers of pedestrians and cyclists. And again, all of them are still there. So staying in British Columbia, the third Johnson Street or Blue Bridge in Victoria, BC, spanned the Narrows between the inner and upper harbors since 1924, serving as a vital transportation corridor to downtown. Increasing concern about the integrity of the bridge and a follow-up condition assessment led to a decision by Victoria City Council in 2009 to replace the 85-year-old bridge. In spite of community backlash, Council confirmed its decision a year later, based on early estimates of $35 million for replacement, compared to about $30 million for a refurbished bridge that purportedly would not last as long. Construction of the new bridge alongside the Blue Bridge began in 2013, and though scheduled to open in 2015, was not actually completed until 2018. And the reason why I'm including this example is that notably by that time, actual costs had risen from $35 million to top $105 million, a clear 3 times the original estimate. Honest numbers matter. Arriving in Ottawa in the mid-1980s on a break from my studies in Winnipeg, I immediately became aware of the variety of bridges here. My first recollection of the Alexandra Bridge during that time was captured on Canada Day 1984 in this photograph, taken from Ottawa Locks, not unlike the thousands of visitors before and after me. In 1987, I began a practicum study at Majors Hill Park, establishing a historical and contextual baseline that naturally included the bridge. Following that turn in Winnipeg and with graduation in 1988, I came to Ottawa and just a few short years later joined the federal government's Center of Expertise in Heritage Conservation. And coincidentally, as seen in this photograph, my first major project for Parks Canada was the rehabilitation of the Ottawa Locks landscape. I was immediately exposed in that group to a much wider mandate and application of heritage conservation principles, practices, and people. One of those people was Guhar Simison, a conservation architect who, in the late 1980s, had been part of a group that advocated on behalf of the Bank Street Bridge. The Bank Street Bridge spans the Rideau Canal linking the Glebe to Old Ottawa south. By the 1970s, the bridge, built in 1912, was falling apart and trucks were banned from using it in 1981. Debate ensued about whether to replace or to restore the Bank Street Bridge with a nondescript highway bridge. A responsible team engaged for the purpose expressed the view that the bridge was in fact reparable. Guhar was one of those passionate voices advocating on behalf of retaining the character-defining arches of that bridge, and ultimately, the decision was made to restore the heritage structure. The work was completed in 1993 and, as she recently told me, was on time and under budget. So it goes to show that you can fight City Hall. And since we're on the topic of bridges in the broader National Capital Area, it's worth mentioning the Chief William Commander Bridge, formerly known as the Prince of Wales Bridge, as David brought up. The Chaudière Crossing, what I call the Museum of Bridges, given that this was the area where Colonel By established the first crossing of the Chaudière. And I would put this challenge to Heritage Ottawa to actually have a session about that Museum of Bridges in some future time. The Laurier Avenue Bridge. This photo was taken during the walking tour that David Jeans conducted a couple of summers ago, and noted that with the widening of the bridge to accommodate more traffic, the substructure trusses were replicated to respect the original substructure. And a little further out, the Wakefield Covered Bridge, just for a quick scan. But back to, and as for our engineering asset guest of honor, I've always loved that turn of the century photograph of the bridge under construction at the turn of the 20th century and its use afterwards. And David's already shown you some of these pictures, including the streetcars on the left and the main locomotive on the right, with the bridge in the background connecting Nepean Point and Majors Hill Park. Of course, since the mid-1960s, thanks to the planning of Jacques Revert and the sequestration of rail traffic away from the downtown core, the bridge was reimagined and repurposed to the vocation that we appreciate and enjoy today. While there were many pleasant surprises through my career here in the capital, there are two which are specifically germane to the bridge. The seminal heritage values exercise that was undertaken in 2006, and as part of a suite of studies of engineering assets across the country in 2010, a follow-up whereby those values of 2006 were confirmed and accentuated. As a professional in heritage conservation, the Alexandra Bridge was the first, to my knowledge, of an engineering asset put to such scrutiny, the next step in the ongoing maturation of the discipline of heritage conservation in Canada. And I draw a parallel with the naming of the Central Experimental Farm as a cultural landscape of national significance back in the 1990s. And on a personal level, as I've stated many times, beyond all the reasons cited by David as to its importance and as embodied in those studies, the stroll across the Alexandra Bridge, including this photo from it, from Gatineau to the Ottawa side, remains my favorite in the National Capital Area. As I described it in my 1988 practicum, a wide pedestrian and bicycle boardwalk developed along the west side has afforded breathtaking views of the hill and Ottawa River environs ever since. Now, one of the reasons, well, the reason why we're gathered here this evening, as David has already noted, is the prospect of the replacement of the bridge. And back in the summer, the board of the National Capital Commission in their meeting reviewed the planning and design principles for the new bridge to take place, including this vision. That it will be, the replacement will be an emblematic bridge in the form of an exceptional civic site reflecting Canada's national identity and values while respecting the integrity of the cultural landscape of the capital. So I'll just leave you to think about that. And then the Advisory Committee on Design provided the 6 bullets there as feedback. You can look at that, and then I'm just going to jump, because the NCC also conducted consultation, and I believe received 2,300 submissions from that consultation. Between ACPIDAR's response and the public consultation, it could very well pertain to retaining the existing bridge that we have today and bringing it up to standards. But I digress. I couldn't help but include these 2 photos because I again keep thinking about how the bridge finds its way in the public subconsciousness. And anyone who watched CTV in the morning will recognize the two co-hosts on the left with the Alexandra Bridge in the background, or the local nightly newscast on the right with the same bridge over the shoulder of the presenter. So just for interest's sake. Back in the summer, David conducted a walking tour on behalf of Heritage Ottawa that began at the National Gallery, moved past the American Embassy towards Majors Hill Park, where we find this three-dimensional bronze depiction of the core. And David made the point, and I agree with him, that the most important structure in that ensemble is the Peace Tower. And as he said at the time, the second most important is the Alexandra Bridge. There was also recent and exciting news about a tram system emanating from the Gatineau side of the river and how and where to end it along Wellington Street. In the before times, I had the opportunity to travel to Portugal, and specifically seeing the tram in Porto in action. Heights aside, this efficient carrier of people without fencing or guardrails once again causes me to reflect on why we're not instituting more of these systems and employing extant elements such as the Alexandra Bridge to complete the loop. And I'm just going to return briefly to the Bennerley Viaduct webinar that I took in. And there are two slides that we could interchange names or thoughts from here to this slide. But as it says in the bottom right, fight to save Bennerley will go on, say groups. So this is sort of the conflict of narratives, negative side. But then there's also the moving together as an organized and cohesive group to achieve positive results. Again, you could substitute pretty much any one of those stakeholders within the context of the Alexandra Bridge. So in conclusion, from my earliest memories of that trestle bridge in the Lakehead to a variety of experiences over the years across the country and around the globe, the idea of bridges resonates still. And as I resist the desire to repeat the salient points of David's, it's worth reiterating the established and collective importance of this node in the core, whether through the lens of world heritage, national significance, or engineering import. And as it was the best and brightest who conceived of and built this bridge, we must unleash the best and brightest of today to maintain her for the benefit of the capital and for future generations. Therefore, in spite of the pressure and continued threat, there is but one thing left to say. The Alexandra Bridge, this bridge, our bridge, is still there. Thank you. Good evening.